I think it can be quite beneficial if you see a tutor or a teacher going through a test themselves and you can follow along and decide whether you would have done the same thing. You can even pause a video as I'm going along and see if you get the same answer using the same method as I do. And it worked really well, I think, for the diagnostic test, which I've already done. One verbal section, one quant section, which you can check out in my playlist. And I got good feedback, so I've decided to do another practice test on McGraw-Hill. Now, there were a couple of problems with the diagnostic test. There was one question in the quant where I believe I found a mistake. I'm pretty certain on that. So this test is not flawless, but I still think it's very helpful because almost all of the other questions were very much like the real test. There were some really hard questions in there as well. And I just think it's really beneficial for students in general to see a tutor do something interactively. Not only that, you saw sometimes where I hesitated or made a mistake, so you can see that I'm not perfect at this either, even though I got a 340 in the real thing. I kind of enjoyed doing the quant section more, so that's why for practice test 2, which I'm going to click on here, I'm going to do the quant sections first, just because I find that more fun. Obviously, if you enjoy the verbal, please do let me know on that too. I have my little notepad here on the right, and I should have a calculator, but obviously I'm kind of ad-libbing a bit here with the software, so let's hope it all goes okay. There was some couple of problems last time, but let's see how we go. Now, with the last test, I said that I wouldn't be teaching as I went along because of the timed conditions, but I did do a little bit of teaching as I was going along, and we'll see how it goes this time. I won't have much time to explain what I'm doing, but maybe just a few seconds per question to explain it. But obviously, I need to finish within the 35 minutes too, so we'll see how it goes. Without further ado, let's get to the quant section. Ooh, it just skipped ahead. 1 second, let's go back. Practice test 2. I didn't want to do section 4, I wanted to do section 3. So let's start with that. Okay, let's do this. X is a positive integer such that x squared is greater than 50. So x would have to be slightly bigger than 7. Notice it said x is positive, so we're not going to be fooled by like minus 7 or minus 8. X has to be positive, so x would have to be slightly bigger than 7 because 7 squared is 49. So that means quantity A is bigger. Quickly double check that. Didn't say, yeah, so it has to be an integer, so it has to be 8. For example, it has to be positive. Yeah, happy with that. Next one. The number of multiples of 9 from 10 to 300 inclusive. Wow, this is a good one. I'm very glad you guys get to see this because people ask me this all the time. What you need to do is, there may be a shortcut here. I'm not entirely sure. But basically, you need to find the biggest one, take away the smallest multiple, divided by the increment plus 1. I'm not sure if I've done a video on this, but we're gonna do this together anyway. Okay, so which one would be the biggest multiple of 9? Well, 300 divided by 9, I obviously could do that in my head, but I'm just gonna save some time. So 300 divided by 9 equals 33 point something, so 33 is the biggest multiple. If 33 is the biggest multiple, we do 33 times 9, and that tells us that the biggest multiple of 9 in that set is 297. The smallest multiple of 9 in that set is 18. Don't need a calculator for that. So biggest take away smallest, the increment, what's it going up by, is 9, and then we do plus 1 at the end. And that's my secret formula. I don't think I've done a video to find out how many multiples there are in a range. Okay, let's do that. Biggest one was 297. The smallest one, let's show this so you can see it, was 18. The increment was 9. And we plus 1. So there are 32 multiples of 9 in that range. So the two quantities are equal. Very, very good. I'm glad you guys saw that. Z is an integer. Oh, it's doing the odd ones again, just like it did last time. Let's see if I can go back to question 2. I'm going to have to do this. Okay, this happened last time. Let's not stress. We're going to do the odd questions first, and then at the end, we can then go back and do the even ones. So the time is going to be a bit misleading because I'm only doing the odd questions. Z is an integer such that it's in between these two. that means Z would have to be 9 or negative 9, because negative 9 in absolute values will become 9, or 8 or negative 8, 10 or negative 10. The number of possible values for Z, that's 6, right? 8, 9, 10, or minus 8, minus 9, minus 10. That's 6 possibilities, that's way bigger than 3, so A is bigger. Happy with that? Lines X and Y intersect to form a 90-degree angle. The product of the slopes of X and Y. Well, when two lines are perpendicular, when they form a 90-degree angle, that means the product of their slopes always equals minus 1. I've taught you in a coordinate geometry video, which I urge you to check out, that the slopes of two lines that are perpendicular are negative reciprocals of each other. But that also means if you multiply them together, those two slopes of perpendicular lines, 90-degree lines, that would equal minus 1. If you try multiplying a number by its negative reciprocal, you always get minus 1. So these two are equal. What I'm very much doing here is teaching as I'm going along. I'm using up my time, but you guys are worth it. Okay, next one. If x plus 3 squared equals 25, which of the following could be the value of x? 2 or negative 8, I would say. Because if x was 2, then that would work out. 2 plus 3 squared is 25. But if x was negative 8, negative 8 plus 3 is negative 5. Negative 5 squared is 25. So negative 8. These questions seem a little bit easy so far, apart from that one with the multiples. That would have screwed a lot of you guys. Okay, let's do this one. A manufacturer purchased an item at 30% less than its production cost and sold the item at a price that was 1/7 greater than what the manufacturer paid for it. Okay, let's use numbers here. Let's make our lives nice and easy. Let's do a new page here. So let's say production cost was, you guessed it, 100. So the manufacturer purchased it at 30% less than that, which was 70, and then sold the item for 1/7 greater than what they purchased it for. 1/7 of 70 is 10. So 10 greater than that is 80. And the price at which the manufacturer sold the item, 80, was what percent of the item's production cost. So 80 is what percent of 100? Well, it's 80%. Happy with that? If A is equal to the product of the positive integers from 1 to 30 inclusive, the product of all those integers, so 30 factorial basically, which of the following is not a factor of A? So when they talk about the product of all the integers from 1 to 30, they're talking, of course, about 30 factorial. I've done a video on factorials, do check it out. Which of the following is not a factor? Okay, this is a classic question. Is 42 a factor? Yes, because if you break down 42, it's 6 and 7, and both 6 and 7 would appear somewhere in 30 factorial. 51 is also a yes. If you break down 51, people think it's prime, but it's actually 17 times 3, good to know off by heart, and 17 and 3 are both inside 30 factorial. 58, if you break it down, 29 times 2, likewise 29 and 2 are both inside 30 factorial. I think the answer is going to be E. We skip to E, which is 62, because if you break down 62, it's 31 and 2, and 31 is not inside 30 factorial. And you can't break down 31 any further. For example, 56, you could say that's 23 times 2, and again, neither of those are in 30 factorial. So the answer is E, because 31 is a prime number that does not appear in 30 factorial. Fairly easy if you know what you're doing. The number of consumers who rated company X as their preferred phone, which would be the XZY bit, XYZ one, so those two sections of the pie, was how much greater than the number of consumers who rated company Y as their preferred phone. Okay, so company X as their preferred phone, that's the 15.3% bit of the pie, because X was first, and the XYZ, so the 18.7% of the pie, because X was first there. You'll get used to these kind of pie charts with a bit of practice. Adding those up, we don't even need a calculator for that. That would be 34.0, so 34%. And we're comparing that to the number who rated company Y as their preferred phone, which would be the two small sections at the bottom, 9.8, 6.2. Adding it up, we get 16. Okay, but these are percents, of course. These are not actual numbers. How much bigger is 34% compared to 16%? That would be, don't need a calculator for that, it's 18% bigger. But they didn't want how bigger it is as a percentage, they wanted the actual number. And notice the small caption, it says there's 1,000 people. So 18% of 1,000 people is 180 people. So that's be 180 more people rated X first compared to Y first. Not too bad if you enjoy pie charts. Okay, next one. In diagram 1, what is the approximate degree measure of the central angle corresponding to the preference YZX? YZX, that's the 9.8%. Well, what are the angles in a pie chart? What do they add up to? 360 degrees, because it's a circle. And if YZX is 9.8%, we just need to find 9.8% of that. Now, of course, 10% of that is 36. So 9.8% of that is slightly less. So it's about 35 degrees. I would have thought it'd be closer to 36, but 35 seems fine. I just double check. I haven't missed anything here. The central angle, I haven't missed anything. YZX, yep, 9.8% of 360 would be about 36, 35. Seems fine to me. Let's do the next one. If the length of a certain square increases by 10% and the width of the square decreases by 10%, the area of the resulting rectangle will be what percent of the area of the original square? Can you guys guess which method I'm going to use? Those of you who shouted out picking numbers, you know me too well. So let's say the original square was 10 by 10, and then the width decreases by 10%, so it's now 9, and the length increases by 10%, so that's now 11. So the area of this one was 99. The area of the original, of course, was 100. The area of the resulting rectangle will be what percent of the area of the original? 99%. Very easy when you pick numbers. Okay, no, I don't want to end the test because now we're going to do the even number questions. Yay! But I would say if this was the real test, I would note down the time, and I'd note that I'm halfway through the test. I've done about 10 questions, but I've only used up 12 minutes. So I'd slow down slightly. I probably won't slow down right now because I just enjoy explaining. If this was the real test, I'd slow down a little bit, double, triple check my answers. Okay, let's do this one. A certain jar contains 5 marbles, R of which are red. If 2 marbles are selected at random and the probability that both marbles will be red is 1/10, what is the value of R? It's a harder question. I think some of you guys will get stuck on this. Now, I could use a fancy formula like saying it's R over 5 times R minus 1 over 4 equals 1/10, where we pick R being the number of red marbles. But to be honest, the numbers are so small, we could literally just use the numbers they've given us. So we could pretend, for example, that R was 2. Always start with B if you're picking numbers from the answers. If R was 2, the chance of getting a red marble the first time is 2 out of 5. But then the second time after you've picked a red, there'd only be 1 red left out of 4. And 2/5 times 1/4 actually, it looks like is going to be 1/10. It gives us 1/10 as the answer. So the answer is B. Now, that was just a lucky guess. I would have done B first, then I would have checked D, and then adjusted to find out which one was the correct answer. This is called back solving, where you start with B, and then you do D. If the answer's between them, you know the answer's C. If the answer's smaller than B, you know the answer's A. If the answer's bigger than D, you know the answer's E. It's a cool technique where you only have to try out 2 of the answer choices. Now, if the probability of this confused you, please do watch my video on probability. Notice I'm doing this test and teaching. I'm still racing through it with way too much time left. Okay, let's do this question. If each of the edges of a cube increases by a factor of 2, then the surface area of the resulting cube will be how many times the surface area of the original cube? Okay, now I could pick numbers, but there is a trick, which I don't think I've done a video, called the Lav principle, where basically you find the scale factor for any one of these, either the length, the area, and the volume. And then once you found the scale factors for, say, the length, then the area scale factor will be x squared, and the volume scale factor will be x cubed. Here, they're saying they're going to increase the length of each side of the cube by 2, which means the surface area of the cube should be increased by 2 squared, and the volume of the cube should be increased by 2 cubed. And they're talking about the surface area, So that's going to be increased by 2 squared, which is times 4. Now, because we have so much time in this test, we can actually quickly check it out. So imagine the cube had sides of length 1. Then the surface area would be, well, each square would have an area of 1, and there's 6 squares, 6 faces on a cube. So the surface area would be 6. If we doubled each side of the cube, so the sides had a length of 2, then each square would have an area of 4, and there's 6 of them. So the area of the total surface area, I should say, of that cube would be 24. And notice the surface area has gone from 6 to now 24. It's got 4 times bigger, which is what we knew already using this LAV principle. Again, I don't think I've done a video on this, but I will do at some point. So the resulting cube will be 4 times the surface area of the original. Very easy if you know the trick. What about this one? The total number of points assigned to phone Z for value was what % greater than the number of points assigned to phone Y for usability? The total number of points assigned to phone Z for value. That would be 4.8, right? Not missing any sections. With these diagrams, always check that you're missing something. Phone Z, a value 4.8. There's no other number they're talking about. So 4.8 was what % greater than phone Y for usability, which was 3.7. Do you remember from my last video, the formula for % greater? You find the difference divided by which one? Which one do we divide by, the 4.8 or the 3.7? If you don't know, pause the video, think about it, because this is what students always get wrong. You divide by the term that came after the word than. So which of the 2 terms came after the word than? Well, there's the phrase than in the middle, % greater than, phone Y. Phone Y came after the word than, so phone Y is our original. So phone Y is the one that goes in the denominator. So that would be the 3.7. And my pen has run out of battery, which is really annoying. So let me quickly pause the video and recharge my pen. That's so annoying. Okay, I am back. I have recharged my pen. And let's go back into the quant section. Timer should be back. Yeah, so I was just saying that for any % greater than or % less than question, the term after the word than is the one that goes in the denominator. That's your original. In this case, that will be phone Y, which was the 3.7. And this, I could do in my head, but why show off? I've just got a calculator here. 4.8 minus 3.7 divided by 3.7. Is 0.297, which is 29.7%. Ooh, which is not on there. Oh dear, what have I done? Did I miss something? Phone Y for usability. What? Total number of points. So the total number of points assigned to phone Z for value, 4.8. So I'm confused. Why are they saying total? It's just one number. Was what % greater than the number of points assigned to phone Y for usability? 3.7. And 4.8 minus 3.7 is 1.1. Divide by 3.7 is 29%. It's 29% greater. What have I done here? I'm missing something. Is the diagram? The total number of points assigned to phone Z for value. Phone Z value is 4.8. Why is he saying total then? Was what % greater than the number of points assigned to phone Y for usability? 3.7. There is no total. What % greater than the number of points assigned to phone Y for usability? 3.7. And that is the formula. You minus it. 4.8 minus 3.7 is 1.1. 1.1 divided by 3.7 is 29%. I have no idea what's going on here. That is the correct answer. I mean, unless there's some chart here, unless they meant to say the total number of points assigned to phone Z for value and something else. But that's just the answer. unless I'm going crazy, unless they're making a mistake in their maths and they want, maybe they meant to say what % less is phone Y than phone Z, like the whole other way round. So 1.1 divided by 4.8, but that would be a completely different question, and that would obviously be 23% was not on there. I don't know what I'm doing wrong here. That seems just a wrong question. Unless I'm going completely crazy, that just seems wrong. So again, you see what you guys get, but I think I'm okay with that one. This one I got, is it not going to let me do? Okay, here we go, question 14. Okay, I'm not even annoyed about that one because it just seems so clear that I'm getting it right. Anyway, if x over y is greater than 1, I would immediately rearrange that, and x over y greater than 1 times both sides by, actually no, I wouldn't rearrange that, let's just leave that. X over y is greater than 1. I was about to say times both sides by y, but you can't do that because y might be positive or it might be negative. You're not allowed to times both sides of an inequality if you don't know the sign of what you're timesing. So let's just leave it like that. And x plus y is less than 0. Okay, which of the following must be true? Is there anything I can conclude before looking at the answers? Let's try and figure out ourselves if we can see anything that must be true here. X over y is greater than 1. You would have thought that means x is greater than y, and that's one possibility, but that's not definitely true. It's not must be true, because it could be something like, I don't know, minus 2 over minus 1, where the negatives cancel. 2 over 1 is greater than 1, and x would not be greater than y in that situation. Minus 2 is not greater than minus 1. So C is not the correct answer, nor is B. It's not definitely true that x is less than y, because again, it could be just 2 over 1, for example, where x is bigger than y. So I don't think it's B or C. And now it says x plus y. Wait. I've got to factor into that second inequality. X plus y is less than 0. If x plus y is less than 0, they can't both be positive. They can't both be positive because then x plus y is not less than 0. Right, so therefore we're back to this double negative scenario. It has to be a double negative. Why does it have to be a double negative? Because the double negative cancels out to leave a positive greater than 1. And why can't it be double positive? Because then it would be greater than 0. It wouldn't be less than 0. So it has to be a double negative, with x being the deeper negative, because if x is the deeper negative, like minus 2 over minus 1, that's why it ends up with being greater than 1, because the negatives cancel, you get 2 over 1, greater than 1. So I think we can actually say that x is less than y, which is not letting me click, like the last test, but that's my answer, because minus 2 is less than minus 1. And we know they both have to be negative for the signs to cancel out. They can't both be positive because of the right inequality. And if they're both negative, x would have to be the deeper negative, the more negative one. So B is true. Now, you can see, by the way, why I rush on some of the other questions to give me more time for questions like this, which are a bit harder. Does x squared have to be greater than y squared? Well, if we've established that x has to be less than y, so it's a deeper negative number, when you square it, it's going to be bigger than y squared, because it's a number like minus 2 compared to minus 1. When you square that, that is bigger. Just double check it can't be like a fraction, but even then it would be a bigger fraction. It would be like negative a half compared to negative a quarter, and when you square it, it will still be bigger. So it's looking like D is also correct. Remember, we know that one's not positive and the other negative, because then this inequality wouldn't be true. You'd have a negative number on the left, which isn't greater than 1. So we know they're both double negative, and we know x is the deeper negative. And if you square the deeper negative, you will get a bigger number than if you square the lesser negative. So B and D looking very good. What about A? Again, if x is a deeper negative, the absolute value of x is going to be bigger than the absolute value of y. Like, strip away the negatives, which is what absolute value does, then the absolute value of x is going to be bigger than the absolute value of y. So I'm going for A, B, and D. Yeah. It's one of those questions I would pick it, and then maybe if I've got time, come back to it, but I'm pretty confident on A, B, and D. But again, it's not letting me pick that. That's what I would pick. Okay. Let's do this one. The greatest possible integer value for A is what? Okay, so this one I would cross multiply because we know the sign of the things we're multiplying. So I would cross multiply and get 100 is bigger than 3 to the A, which if you rearrange or just say the other way around, 3 to the A is less than 100. What's the biggest integer value for A? Well, A could be 1, A could be 2, 3 squared is less than 100, A could be 3, 3 cubed is less than 100, A could even be 4. 3 to the power of 4 is 81, that's less than 100. But A couldn't be 5, because then it would be greater than 100. So the biggest possible value for A is 4. Happy with that? If x and y are integers, and that equals that, what is the value of x plus y? Okay, let's just write this properly. So x to the minus 3 is 1 over x cubed. Y to the minus 2 is 1 over y squared. And that equals 72 to the minus 1, which is 1 over 72. If we cross multiply that, you're hearing this word cross multiply a lot because I use it a lot in tests, and you get that. Breaking down 72, prime factorizing of course. 72 is 8 times 9, 8 is 2 cubed, and 9 is 3 squared. So we basically know what the values are. X is the 2, y is the 3. Ah, you know what? They're actually really naughty. I've actually spotted an error in the question because x would definitely have to be 2, right? If you compare the two sides of this equation, x would definitely have to be 2, but y could be 3 or negative 3, and it would still end up equaling both sides because negative 3 squared is still equal to 3 squared. And so we don't actually know whether y is positive 3 or negative 3, and they never said x and y are positive integers. Now I'm assuming that they mean 3 in the positive sense. So x plus y is 2 plus 3, which is 5, but that's very cheeky, very bad question because y could be negative 3 here. And there's no reason why it wouldn't be. Yeah, 3 to the minus 2, sorry, negative 3 to the minus 2 is just exactly the same as 3 to the minus 2. So we have no idea what y is, and there's no indication that it can't be a negative. So I'm assuming they mean the positive version, 2 plus 3 is 5, but they could have meant the negative version. So in the real test, obviously, they won't allow that possibility, or there'll be multiple correct answers. But for now, I'm guessing they mean the 2 plus 3. Let's double check. There's nothing to say. No, there's nothing to say that it could be 3 or negative 3. It could be either of those. That's a badly phrased question, to be honest. Okay, this one. Running a little bit low on time, I guess, but should be fine. A is greater than B, which is greater than K, which is greater than 0. What's bigger, A over B or A plus K over B plus K? Obviously, we could pick numbers. But just logically, if we add a small number to top and bottom, are we making the fraction bigger or smaller? Like if you have 3 over 2, is that bigger than if you just add 1 to top and bottom? I'm picking numbers here, but I think there's a way to do this just logically. If you just add 1 to top and bottom, is that always true? This would become 4 over 3, which is smaller. 4 over 3 is 1.3, 3 over 2 is 1.5. So it's smaller. Is it always true that you're making it smaller? Is that always true though? If you add a smaller number, I guess you're making that number closer to 1. By adding the same thing to top and bottom, it's like you're adding... I'd probably at this point pick some fractions, like if k was a half, but that's still that would still be smaller, right? 3.5 over 2.5, which is 7 over 5, which is still smaller. Seems to be no matter what numbers I pick, it gets smaller. Unfortunately, I'd love to think about this one a bit more, but I don't have the time. So it's just based on these examples, it's looking like quantity A is bigger. That's a really interesting one. I think there's a logical reason there, I'm sure there is, to do with the fact that you're making the fraction closer to 1, and therefore, given that we know the fraction is greater than 1, because A is bigger than B, so A over B is bigger than 1, and if you make the fraction closer to 1, you're making it smaller by definition. Okay, I'm happy with that. I don't really have time to explain it though, but I'm happy with that. Okay, this one. Ooh. 1 over root 1, which is just 1 over 1, plus root 1 over 3. They're asking, is that bigger than 1 over root 1, which is again 1 over 1, or 1 over 4, or rooted? I talked about in one of my quantity comparison videos, there's a shortcut you can do, which is quickly pretend that they're equal and solve the equation. Take away 1 from both sides. So we're actually now finding out, is root 1 over 3 bigger than root 1 over 4? Well, if you square root a fraction, you square root top and bottom. Square root of 1 is 1. Square root of root 3 is root 3. And square root of 1 is 1. Square root of 4 is 2. Now, root 3 is slightly smaller than 2, right? Root 3 is like 1.7. But if we have a smaller denominator, that means that we have a bigger fraction. So this fraction is bigger, therefore quantity A is bigger. Happy with that? This may be the last one. Well, I think question 2 I skipped also. Okay, so I've got 2 more with about 2 minutes each. Okay. Circle C has a diameter of length D. Quantity A, pi, or the circumference of the circle. C over D. What is going on here? Quantity A is pi. Quantity B is the circumference of the circle, C over D. Are they telling me the circumference? What's going on here? Maybe quantity A is meant to say the circumference of the circle? The software is letting me down here again. Well, anyway, if it has a diameter of D, the circumference would be pi D. Well, pi D, are they trying to say, is that bigger than pi? Quantity. I'm just going to pretend that quantity B is just the circumference of the circle, which is pi D. But we don't know if that's bigger than pi, because D could be like 0.5. So I'm ignoring that C over D thing. I don't know what they're talking about. I'm assuming quantity B is just the circumference of the circle, in which case the answer would be D, because we don't know whether that's bigger than pi. It depends on what the diameter is. Is it a fraction or is it not? Okay, 1 minute for this one. The number of hours Bob worked in December was 10% less than the number of hours he worked in November. Bob's hourly wage in December was 10% more. Okay, you know what I'm going to do here. You know I'm going to pick numbers. So let's say he worked 10 hours in November. In December, therefore, he worked 10% less, which is 9 hours. Bob's hourly wage in December was 10% more than his hourly wage in November. So in November, let's say he's paid $10 an hour. In December, he's now paid $11 an hour. So his total earnings in November was 100. Total earnings in December was 99. You just multiply the hours by the wage. And so he earned more in November. Okay, so confident with that one. Confident with that one. I showed you that trick. That was probably one of the hardest questions, but I showed you the trick there. Confident with that one. Confident with that one. That was a great trick. That was quite easy. That was quite easy when you pick numbers. That was good to do with factorials. Many of you would have got that wrong. That was quite easy if you know pie charts. Quite easy if you know the angles in a pie chart is 360. Pick numbers. This one you could pick numbers or use algebra. That one was the love principle, which is a great principle. I should show you on a video one time. This was the weird one. I think the answer is 29%. I don't know what they're talking about. That one was fairly hard, but I'm confident. This one, very confident. This one was weird. I think there's an error in the question. And I'm running out of time, so I just have to click to the end. Yes. Okay, let's see how many I got right here. This one. Quantity A is greater. Yep, that was fine. That's fairly easy. This was good. Oh, wow. They used my same formula. Last minus first over spacing plus 1. I haven't seen other people use that. There you go. So they're confirming that is the best formula. You guys are getting the best stuff here. That was fairly easy. Again, pause the video and look at the explanations if you didn't like my ones. But I kind of explained my reasoning as I went along. That was fine. That was fairly easy. That was fine. You pick numbers. That was fine. You need to know about factorials and prime factorization. Correct answer B. Did I get that? I presume so, yeah. 16%. Okay, I think I used a different method, but I did get 180. 9.8% is 35. I got that. That was fine. This was fine. You could pick numbers or do algebra as they've done. Let's get to that question. Okay, this was fine. Just use the Lav principle. This one, here we go. Since these ratings are averages, where does it say that? You may be inclined to get the sum of the value ratings for each and then use the percentage change formula. However, we don't need to get the sum since the number of ratings is the same for both groups. Am I missing some sort of caption? There was no caption here. What are they talking about? Instead, use the average rating in percent change formula. What are they talking about? I think there was some caption that they missed out here. Again, I'm sorry that this question didn't live up to the other questions, but I have no idea what they're talking about. It never says these ratings are averages. Like, there's probably some caption on this question that I just can't even see using this software. But again, obviously I couldn't get that right because I can't see the caption. Okay, that I got right, even though they didn't let me put it in. Did I even pick numbers? I can't remember. I think I just used logic. And I did pick numbers, -2 and -1, but still, I tried to explain it using logic. That was fine. Cross multiply because I knew the sign. Here we go. This one, I got 5, right? But do they address that weakness that y could be -3? First, get rid of the negative exponents. That's what I did. Then I prime factorize. That's what I did. They've ignored it. They've ignored the fact that y could be -3. So I found another mistake in these questions. Now, obviously, I'll admit to you, these questions are not perfect, but if you're good enough at the GRE, you can even find mistakes in these questions. So I still would say you could do these tests if you have the spare time. Obviously, I do recommend more the ETS practice test and Manhattan and Kaplan practice test, but these are free. And if you get really good enough with the practice, you can even start spotting mistakes like I did here. Because y could definitely be -3, so we don't know whether the answer is 5 or -1. So we've even spotted a mistake, which is great. That was fine. Kind of pick numbers and also use logic. They pick numbers, which I quite like. That was fine. I used that quantity comparison shortcut trick that I mentioned in one of my videos. And this one. Okay. So the circumference of the circle is pi d. Pi times d over d. Yeah. I think they meant to say in quantity B, I think they meant to say the circumference of the circle C divided by D. Like the divided by D should go across the entire quantity B. But obviously that's not clear from the software. But that's fine. I think most of you guys know that the circumference of a circle is pi D. So that's fine. This one was fine. You pick numbers. And I think I've done all of them now. Yes, I've gone through all of them. So there were some really valuable questions in there, like this one, using my trick, last minus first, or I call it biggest minus smallest divided by increment plus 1. There's some other questions that really were great, like that was a good practice of absolute values if you weren't familiar. That was a great one about perpendicular lines intersecting at 90 degrees, but also if you multiply the slopes, you get -1. So it's great learning points. Obviously, we had the distractions of the couple of errors in those questions, but look how often we talked about picking numbers as well. That's a great learning point for you guys. Not enough people do that. We talked about factorials as well. So really interesting test, worthwhile going through. I believe I got 100%. Obviously, I didn't see the caption on that question, but that was fine. That was really enjoyable. Hope you enjoyed it too. Please do leave a comment if you did, and I'll see you in the next video where I'll do verbal or maybe the next quant section.